Hi everyone, today we're going to be talking about lesson 7.5, properties of logarithms. And right off the bat, I'm going to ask that you pause the video and go ahead and write these properties down so that you're not scrambling to write as I describe them. So pause the video, write all of this in your notes, and then come back here to hear what I have to say about the different properties. Okay, let's go ahead and talk about these properties. We have the product property, quotient property, and power property, and you're going to see that they're a little bit similar to the exponent properties that we've discussed before. For example, our product property, if we have log base b and we are multiplying two things together, m times n, then we can rewrite it, break it apart, and say that that's the same as log base b of m plus log base b of n. Now remember when we did our exponents, when we multiplied exponents, we added together. So here's that multiply and add showing up in our logs. The quotient property says that if we have log base b of m divided by n, we can also break that apart and say that it's the same as log base b of m minus log base b of n. Remember back in exponents, when we divided, we subtracted exponents. Well, here we're dividing and we're subtracting logs from each other. Our power property says that if we have log base b of m raised to the n power, that n power can come out to the front and be multiplied by the log, similar to the power of a power property with exponents. When we had exponents that were a power to a power, the powers multiplied. Here we are multiplying the power times the log. Also note that these are equations, so they actually work in either direction. They're written this direction to expand them, but we can also start with something that's expanded and condense it instead. So we'll be working with the equations both directions today as we continue. The first way that we're going to use our properties is to approximate some logs. Remember that logs are usually rounded to the nearest thousandth, but it does mean that they are approximations and not exact. So we are going to be given two pieces of information. That log base 2 of 3 is about equal to 1.585, and that log base 2 of 7 is about equal to 2.807. And using that information, we want to evaluate 4 different logs. This first one is log base 2 of 3 divided by 7. Well, I don't know what the log of log base 2 of 3 divided by 7 is, but if I break it apart and create a subtraction out of it, look what happens. I can say log base 2 of 3 minus log base 2 of 7. That uses our quotient property. And now, well, I know what log base 2 of 3 is. It's right here. And log base 2 of 7 is right here. So I can simply substitute, plug that in, and get my value. So I will say 1.585 minus 2.807, and if you put that in your calculator, you're going to get negative 1.222 as a final evaluation of that log. Let's look at the second one. We have log base 2 of 21. Well, I don't know what the log base 2 of 21 is. However, I notice that 21 is the same thing as 3 times 7. So I'm going to break that 21 into two parts, a 3 and a 7. Once I break this down into 3 times 7, then I can see that I can use my product property. So I'm going to use product property next, because that says that log base 2 of 3 plus log base 2 of 7 is the same thing as log base 2 of 3 times 7. Now I know what each of those is, and I can just substitute 1.585 and plus 2.807, And when you put that in your calculator or just do it by mental math, 4.392 is my final result. The next one is log base 2 of 49. Again, I don't know what log base 2 of 49 is, so I need to break this apart, break it down. And 49 is 7 times 7, so I can say log base 2 of 7 times 7 and then use my product property again, because I know that the log base 2 of 7, I know what that is, and so I just have 2 of them. So that's going to be 2.807 plus another 2.807. Add those together to get 5.614 as a final answer. Let me show you another way to do that instead of breaking it into two things and multiplying. On this next one, what we're going to do is rewrite 27 as several 3's. Remember that 3 cubed is 27, so I could go ahead and break 27 down as, start with my log base 2 of 3 raised to the 3rd power. I can put that in parentheses if I want to, just to make it a little clearer. Once I break this down, I have an exponent, so I can use my power property to rewrite this, bringing the 3 to the front and multiplying it by log base 2 of 3, which I know what that is. It is 1.585 from above. And so our final answer for this one, when we multiply by 3, is 4.755.